To solve trigonometric equations. So before I write down anything, I actually want to just see if you guys could solve this example. We'll do it together. So here's an example of a trigonometric equation, right? So it might look complicated because it has this sign in it, but it really isn't that much different than if this sign of theta were just an x. Something like that. Okay? It's really the same thing. So imagining this is just an x, what would you guys do? What do you think we'd do to solve it? Yeah? Okay, move the 1 over. Right. We get 2 sine theta. 1, right? And just envisioning that sine of theta to be an x. I'm just going to imagine that's the case, right? Okay, then what will be our next logical step? 5 by 2, or inverse operations. So then we have sine theta equals -1/2. Okay, so pretty good so far, right? That's just an easy equation like you did in 6th grade, right? The only difference is we got a sine theta instead of an x, right? That's easy. Okay, so the question is, how do we now then solve this? The goal is to solve for theta. Theta is like an x. It's just when we solve for angles, we use a theta instead of using an x. So kind of similar. So basically, what do we do that it's not the answer because we don't have just theta. So how do we solve that? Somebody have a guess what they think the answer is?
Does it make it positive?
But it's a good thought.
It's too high.
Anybody have an idea? Okay, let me ask the question this way. Where is sine of theta equal to -1/2? So all I did was just state out that in words. Where is sine of theta equals -1/2? And all I did was this again on the unit circle. Yeah, so there's actually a warm-up question in there. It was the same, where we just had 7 pi over 6 right here, right? That coordinate pair at 7 pi over 6 is negative radical 3 over 2, -1/2, right? So the sine of theta, sine of the angle, is -1/2. And that's one of them. So theta equals, now this is where it's different. Instead of what we've been doing is we've all been saying like coordinate pair. Now we're kind of doing the opposite. We're given a coordinate pair. We're given that it's -1/2, and we're going to give the angle. So we're going to say the angle, which is 7 pi over 6. Right. And there's another one. Yep. Where is that one? Next, so if we work our way around this circle a little bit more, you'll also see over here. It should be 11. Yeah. Radical 3 over 2. -1/2 right here is 11 pi over 6. So there's actually 2 places where the sine of theta is -1/2. 7 pi over 6 and 11 pi over 6. This has 2 answers. So we're kind of working in reverse from what we've done before. We're getting the sine of theta by itself, and then instead of saying, here's your radian value, give me the coordinate, we're saying, here's the coordinate, what's the radian value? So it's just kind of answering the opposite question. And so really just kind of 2 basic steps we've done. If you like to write down steps, go for it. We're going to just use our inverse operations. So like we just subtract 1 and then divide it to get the trig function by itself. In the same way that you would treat it as an x. Just get the function by itself. Stuff you've been doing for years, right? Add or subtract and then divide. And then after that, we're going to find the unit circle radian value, like we did here. We found the radian value that matches that coordinate. We just find, and that Notice I also put an S on there for the values. Generally, there'll be more than one place. There could be one, could be two, there could be four. So all of the values that match that one. Generally, it'll be two, sometimes four, but it could be one as well. So that's our general strategy. We'll add some more notes to this in a minute, but that's our general strategy. There's actually a way you can do this on your calculator as well. It's called taking the inverse sign of this. We're not going to get into that right now, but there's another way you can do this on your calculator as well. All right, let's try a couple more examples. Let's try this one up here. 2 cosine of theta plus 3 equals 2. So maybe take a second and see if you can get the cosine by itself there. If we got cosine theta is negative a half, right? So now this is the question we think. We think, where is cosine? In other words, the x coordinate, right? Cosine of the x. So where's the x equal to negative a half? So we just look at our unit circle. Where is the cosine of the x coordinate? Negative a half. There should be 2 places. So negative a half would be here, right? And here. I'm sorry, here and so that would be here and here. So what are those 2 values? Yeah. Yep. 2 pi over 3 is up here. And down here is the 8 pi over 3. Or 4 pi over 3. You said 8 pi over 3, right? Okay. Yeah, 4 pi. And you can look at your unit circle if you need to for that. Those are going to be the 2 places where the x is negative. This one will be negative a half positive radical over 2, and this is negative a half negative radical over 2. So those 2 answers. So hopefully it's kind of connected, making sense, right? I'm looking for the opposite thing. So the next one here, we have a tangent of theta plus 1 equals 0. So obviously solving for tan is not going to be too hard. Tangent of theta will just be negative 1, right? Now this is where it gets just a little bit more challenging because tangent isn't just an x or a y, it's an x and a y put together, right? Tangent is, here's the question we're asking. Where is y over x, right? That's what tangent is, equal to negative 1. It's a little bit more challenging because we got to think of this as a fraction. But it isn't too bad when you think about what's going to give you 1 or negative 1. What are the places that would give you that? Right, all the fourths. All the fourths you'll get 1 or negative 1 because that's where there's the radical 2 of the 2's, right? So let's think about this in our unit circle. We know our possibilities are all these quarters, like pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And again, all of those because they have the radical 2 over 2's, radical 2 over 2 equals 1, right? But we need it to be negative 1, so we need to choose it won't be all of these. Which 2 would give us a negative 1? Facing you? Good, these 2. Because these 2 both have a negative and a positive. So here it's a negative x positive y. Here they're both positive, right? Here's they're both negative, so you do a negative over negative and then a positive. It's not a positive negative. So these two, the second and fourth quadrants. So theta then would be 3 pi over 4 and 7 pi over 4. Now it can get a little bit harder than this. I put some hints here that may help you a little bit, but it is a lot of writing, so if you don't want to write it, that's fine. But I'm going to show you here. We haven't got to any cosecants or secants yet, but we'll get to that really soon, and this hint will help you here. So if we're asked to solve for a cosecant or a secant, maybe we'll like skip ahead here a second and show you one. Let's go back. All right. So for example, this one, let's do it as we're going here. So if we're asked to solve for a secant, in this case, it could be a cosecant either. Well, all right. First thing we would probably do is just get the secant by itself, right? So we're going to minus our 6. 4 secant theta equals negative 8. So then we divide by 4. Secant theta is negative 2. All right, so this is a little bit challenging because it's 1 over something, and we get a negative 2. Do we know an easier way we could look at this? Here's the hints. Right? Yeah, you just flip it back, basically, right? That's it. So that's the hint. You can't really see it very well. So if you're solving for a cosecant or a secant, we're actually going to change it to a sine or a cosine. And then you're going to also take the reciprocal. We're going to change it to a sine or a cosine. Because you can do that. They all have pairs, right? And then you're just going to flip it. It's a lot easier to think of a sine or cosine because we know those are just x's and y's. So basically, we just flip both sides. We take the reciprocal. So instead of having secant of theta, what would we write that as? Cosine or sine? Yep, cosine is the opposite. So we write this as the cosine of theta. But since we changed this, since we flipped this side, we got to flip this side also. So it actually just becomes negative half. So we just flip them both. We flip the secant and the cosine, and then we flip the fraction. Negative half. And that's a lot easier, right? Because then we can just look, then this is basically just where is x equals to negative half. We've actually kind of already answered that one before. So we're x is negative half, or I guess, sorry, theta. Right, that's going to be where theta equals 4 those 2. A lot easier to answer that question. So whenever you end up with a secant or a cosecant, just flip it and make it a lot easier. All right, our second hint is actually one we already did. There's a couple for solving the tans and cotans. Those are generally going to be the hardest, tangent and cotangents. So if you're solving for a tangent or cotangent, and you get a 1 or negative 1, like we did, it's always going to be a pi over 4 multiple. So it's going to be like pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So if we ever get plus and minus 1 with a tan or cotan, we know it's got to be this radical 2 over 2s over radical 2 over 2s, which means a pi over 4 multiple. So just some hints again. If you don't want to write them down, that's fine. That might be helpful. And then the last one, I don't think there's an example of this one, but this scenario could pop up, and we'll practice these some more tomorrow, so should see one like this tomorrow. If you're another one for tan and cotan, if we get just, our answer is just radical 3, then the square root of 3 over 2 is on top. And I'll explain to you what that means. And then we could actually add a little extra to that as well. One of your homework problems is kind of similar to this. I'm going to add one more statement. If you get, this will help you. Radical 3 over 3, then 1/2 is on top. Okay, that might not make that much sense right now, but I'll explain it later. Got a few more problems to try. Let's do one more here. Move that one. Okay, next one here. This one looks a little more confusing. 3 radical 2 cosine theta plus 2 equals -1. This 3 radical 2 is just all one term, 3 squared root 2. And cosine of theta plus 2 equals -1. So what should we do first for this one? Yep, always subtract 2. It's like the opposite of order of operations. So we cross it out. 3 square root of 2 cosine of theta equals -3. Three radical 2, again, is just a single thing. So we're just going to divide it out. So we divide both sides by 3 radical 2. And then we're left with just cosine. And the 3's are going to cancel here too, right? So we just get -1 over radical 2. Now that's not a unit circle value. But how could we make it look like a unit circle value? What's rule did we violate here? Yeah, you can't have this in the bottom. So let's go ahead and just get rid of it from the bottom. To do that, we'll multiply by radical 2 over radical 2. So we get cosine of theta. On the top, we just get negative radical 2, right? And on the bottom, they cancel and give us just 2. And that looks more like something we actually get, right? Negative radical 2 over 2. So it is possible that you might need to change it a little bit so it fits to something that's on the unit circle. So then the question we ask is basically, where is the x, because that's cosine, where is the x in negative radical 2 over 2? So let's think about a unit circle. Now this is going to be one of the pi over 4s, right? So either here, 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 because that's where radical 2's are. And where is the x negative? The x is negative over here in these two quadrants. Negative x, negative x.
How do you know that?
So this is 0, 0. It's just like within 0, 0. And so this is positive numbers in the x, right? This is negative in the x.
Okay.
Right. And those are going to be your two negative x values. So here this is when theta equals, this is 3 pi over 4. That one, and then this one is 5 pi over 4. And you can use your unit circle. you don't know that. That's okay. Hopefully you're getting there. Starting to click hopefully a little bit. Alright, got two more for you. Some squares in here. Alright, now one note before we do this. This is how it's written, cosine squared theta. You might not have ever seen anything written like that before. Cosine squared theta. Sine squared theta are written the same way. Tangent squared theta. What this means is it's the whole cosine theta, the whole thing squared. Just we write it that way in math. You just write the square here and in between the two. That means the whole thing squared. It is. You would not write it if it was written this way. Cosine of theta squared. What that would imply would just be the cosine, and then only the theta part would be squared. So that's because it gets confusing. You don't really know. So that's why they write it there instead. So we shouldn't really see it written that way. This thing means the whole thing squared. We should have to remember that. All right, we're going to solve it the same way. We're going to divide by 4 first in this one, right? So we get cosine squared theta. And then, just like you would do with anything, if it was squared, you'd do the opposite, which is square rooting, right? So square root both sides. The square root of cosine squared then is just cosine. Alright, now when you take the square root of a fourth, you take the square root of the top and you take the square root of the bottom. We also need the plus or minus there as well. So plus or minus square root of 1 is 1, square root of 4 is 2. So it's plus or minus 1/2. Those are numbers we have underneath a circle, so we can work with that. But this one is plus or minus, so there's actually going to be 4 answers. All the places that the x coordinate is either positive 1/2 or negative 1/2. So the x coordinate here is going to be 1/2, right? And over here it's negative 1/2. Here is going to be negative 1/2. Here's positive 1/2. So kind of the 4 there. And if you need to look it up, again, perfectly fine. You don't have to know that. Alright, so what's the first value there where it's 1/2? Pi over 3. And the next one? 2. And down here. And last one. So those 4 answers there. You'll have all 4. All the places where the cosine is either positive 1/2 or negative 1/2. All right, last one. Let's give it a shot here. 2 sine squared theta minus 1 equals 0. So first thing, we'll just start by adding the 1 over. Two sine squared theta equals 1. Divide everything by 2. Okay, sine squared theta equals 1/2. Yes. No, good. All right. And last thing, take the square root. So the square root of sine then is just sine square of sine. All right, now this one's going to be a little bit more challenging. because we get square root of 1 is 1, right? You need the plus or minus. But then we have 2, that's not a perfect square. So it's actually 1 over the square root of 2. So then what do you think we do from there? Yeah. Yep, factorize multiply by radical 2 over radical 2. So then we get plus and minus radical 2 over 2. So we want to know where the sign is plus and minus radical 2 over 2. Sign is the y coordinate, so that's the question. Where is y plus or minus radical 2 over 2? So let's think about all of them, right? Plus or minus would actually be all of the quarters, right? So all of these 4 places is going to be either a positive radical 2 or a negative radical 2. Then get that 5 over 4, 3 5 over 4, 5 over 4, and 7. All those places. That's it. So you got the rest of the period to work on some problems. I can help you if you get stuck. There is a couple that are kind of challenging. Unfortunately, the ones in the book ended up being harder on the evens than the odds. There's a couple, but if you get stuck, I'll help you. And if you get completely stuck, it's okay to do your best and then move on to the next problem. But just 7 problems. So go ahead and give those a shot, and it is uploaded online already on Google Classroom.